Hello guys, so in this video, whenever we're given two vectors and we're given the projection of one vector onto another vector, we apply this formula, which is the projection of u onto v is equal to u dot v divided by the magnitude of v squared times our vector v. So the key word is onto. So if it's u onto v, you include the u once. V onto u, you include the v once and the u is all the other times. So I'm gonna just write that as a quick rule of thumb, because that gets people, because they don't know which one is u, which vector can I call u, which vector can I call u. In this case, it's given to us, but sometimes it may not always be given. So the key word is onto. So I'll just use, for examples, I'll just use vectors a and b. So a onto b is equal to the projection of a onto b. And then you would write it like this. The a would come once, and the b would be the one that fills up all the other spots. So that's one of the trickier parts of this, is knowing which vector to compute the magnitude of and which vector to multiply by. So that's the keyword is onto. So just follow this logic, so that way you don't trip up on these type of problems, because you could probably miss this problem if you don't know which vector is onto which vector. But basically, if you follow this example right here, it'll work for every example. So without further ado, we're going to compute this vector u onto v, the projection of vector u onto vector v. So without further ado, the first thing we do is we're going to go ahead and find the cross product. So, or the dot product, sorry. Find u dotted with v, and we're taking the dot product. So in doing so, by taking the dot product, we get u dotted with v is equal to 4, 0, 1 dotted with 5, 3, minus 7. And then when we dot these, we get u dotted with v is equal to 4 times 5, element by element multiplication. If you don't know how to take a dot product, I have a video on that, which I think is essential for calculus, for Cal 3 especially. So 20, plus 0 times 3 is 0, plus 1 times negative 7 is minus 7. So this equals negative 13. This is our dot product. So the next step, our dot product is negative 13. The next step is we're going to go ahead and take the, we're going to find the magnitude of vector v. So the magnitude of vector v is, and then we're going to square it. So the next step is to find the magnitude of vector v, and then square. So without further ado, our vector v was equal to 5, 3, minus 7. So I'll write that down. So the magnitude of vector v squared is going to be equal to 5 squared plus 3 squared plus negative 7 squared. Inside a square root, and then we're squaring it. So basically the next step is just to take these terms, 25 plus 9 plus 49. 25 plus 9 is 34. 34 plus 49 is 83. So this is equal to 83 squared, and square root and the radical cancel out. So this would just be 83. So this is our the magnitude of v squared. So the next step is we're supposed to plug into formula. So in doing so, when we plug this into the formula, we get negative 13, which was our u dot v. Our formula is right here. This is the formula that I'm using. U dot v divided by the magnitude of v squared times our vector v. So u dot v, we got negative 13. So projection of u onto v is equal to negative 13 divided by 83. And then our vector v as stated in this formula right here. We're multiplying this by our vector v, and we should get a vector, not a scalar. Minus 7. And you can either leave the answer like this, or you can simplify it further. You can distribute this into each term. I'm not going to for simplicity's sake. I'm just going to leave it like this. But you could. Actually, I will. I think it's very easy. 13 times 5 is negative 65 divided by 83. Negative 39 divided by 83. And then 13 times 7. Ooh, okay. 65 plus 20 is 85, 91. 91 over 83. And this is our equal to our projection of u onto v. Is this vector. Always get a vector, never a scalar. Anyway, so quickly in retrospect, we're going to go over what we did. So first, we're given this formula. So first we have to identify which vector is onto which vector. So if it's a onto b, we include the a once, and we're taking the magnitude of v. If it's b onto a, however, then we will take the magnitude of vector a. I think that's the tricky part. From there, you just compute this formula right here. So we take the dot product of u dotted with v. We got this scalar value. And the next step was we took the magnitude of v squared. So we take all the v components of this vector, square them, add them together, square root, but then we're squaring the magnitude. So we get this scalar value. Then the next term is we plug it into the formula. U dot v divided by the magnitude of v squared times vector v, and then we get these terms right here. So I hope that was helpful. Thank you for watching. Hello guys, so in this video we're going to find how to find the projection of vector u onto vector v. So in this problem we're given two vectors. We're given these two vectors right here, vector u v and vector u, and we're trying to find the projection of u onto v. So one thing I will say is one of the trickier parts of this problem is not knowing which vector. So notice this formula, u dot v divided by the magnitude of v squared times our vector v. One thing I want y'all to notice is that u is only on there once. V is on there multiple times. V, the magnitude of v squared, and our vector v. So a lot of people confuse which magnitude do I take? Do I take u's magnitude or v's magnitude? Because at the end of the day, these are just these are vectors, but we don't know which one to call u and which one to call v. So the key word right here is onto. So let's say, for example, if it was vector v onto vector u, then the projection, then the formula would look like this. So instead of u onto v, we would flip these. V onto u, which is equal to v dotted with u divided by the magnitude of u squared times vector u. So yeah, it's tricky. It's tricky. The keyword is onto. So whichever one is onto, only included once. So whichever one is onto the other is only included once. Whichever one's the one on the bottom, whichever one you have right here, you're going to take the magnitude of that one. All right, so that's just a quick little concept check because this one's projection vector v onto vector u onto vector v, but they could flip it on you. They could give you two vectors, not call them anything. and then they could say one's onto the other. You have to know which one to take the magnitude of. That's the key step. So anyways, without further ado, we're going to go ahead. Now that we know that, we're going to go ahead and just start computing the projection. So the first thing we're going to do is we're going to find the dot product of u dot v, because this one's asking a vector v onto vector u, onto vector v. So u will be only included once, and this is the formula that we're going to use for this one. So we're finding u dot v, which is the dot product. So u dot v, so our vector u dot v would be equal to, what's our u vector? Is 4, 7, 0 dotted with 6, minus 3, minus 2. And when we dot these, if you don't know how to take a dot product, I have a video on that. But for this video, I'm just going to compute it. 7 times negative 3 plus 0 times negative 2. And in doing so, this is 0. 24 minus 21. This would be equal to positive 3. So that's our dot product. So all I did was just simply compute the dot product of these two vectors. Now for the next step, we have to compute the magnitude of vector v. And knowing that it's projection of u onto vector v, we know that we're computing the magnitude of vector v. Since it's onto, we're only including the u once. So now without further ado, we're going to find the magnitude of v squared. So our vector v is 6 minus 3, 2. And then to compute the magnitude, we just take the square, we square each term, take the square root, or add the terms together, and then we take the square root. So 6 squared plus negative 3 squared plus negative 2 squared inside the square root. And then since we have this square, we're squaring it as well. So 36 plus 4 plus 9. 36 plus 13, 49. So 49 square rooted. Then we're squaring. So the square root of 49, the square root of 49 is 7, but then we're squaring it. So it's actually essentially just equal to 49. So this is our magnitude of vector v squared. So now the next step is, given these two terms, is to plug in the formula. What was the formula again? The formula was the projection of u onto vector v is equal to u dot v divided by the magnitude of v squared times the vector v. So notice how the u is only included here once. So we're going to multiply our u dot v. So our u dot v, what was our dot product? It came out to be positive 3. Our magnitude of v squared, which is this component, it comes out to be 49. And then we're multiplying it by our vector v. Our vector v was 6 minus 3, positive 2. And the next step would just be simply to just simplify this. So the projection of vector v is equal to 18 over 49 plus negative 9 over 49, and then 6 over 49. And that's our final answer. So that's how we find the projection of u onto v. So in quick retrospect, what did I do? First thing is I read the problem and it said vector u onto, keyword vector v. So what did that tell me? That told me to include the u one time because it's u onto v. So we know we're going to take the magnitude of v and not the magnitude of u. So, and then this is the opposite. V onto u, we would include the v once, and then we would take the magnitude of u. Key step. That's honestly the key step, because that's where most people, they mess up, because the computation's easy. But the hard part is knowing what to compute, magnitude of u or magnitude of v. So afterwards, we just took the dot product, u dot v, easy stuff, element by element multiplication, add them together. We got 3. Then from there, we took the magnitude of vector v, and then we squared it. So we got 49. Square root of that is 7, but when you square that, it's 49. And then we plug it into the projection formula. We did all this arithmetic. Dot product divided by the magnitude of vector v squared, and then we distributed into our vector v, and then we got this answer right here: 18 over 49, negative 9 over 49, 6 over 49. If your answer doesn't match, you probably messed up somewhere. Other than that, thank you for watching. I hope that was helpful.